So this video is going to help us to write the rule for linear functions. And once you recognize you really only need two pieces of information and know where to put them in the equation, it's really not that difficult. You need to know the slope, whoops, and you need to know the y-intercept. So you need to know how fast it's growing and where it crosses the y-axis when x is 0. So before we start talking about where to look in the equation or the table or the graph to find the slope, let's make sure we understand the different kinds and how to read it on a graph. Positive slopes, remember we read our graph from left to right. So if you feel like the line is climbing up, like you'd be going up, then it's a positive slope. Once again, reading from left to right, if you feel like you're going to be falling down, then it's a negative slope. And also a piece about negative slopes that's important. When you're reading your slope and you do a slope triangle, for example, and you read it as down to horizontal change of 3, that's the same thing as if someone else reads it as up to and back 3. And you can write the whole thing as negative 2/3. All of them are exactly the same, just it's really important that somewhere in there we have one negative, so it's showing a downward slope. Horizontal lines have a slope of 0, and we name them based on where they cross the y-axis. So if it crosses at 3, for example, we'd say y equals 3, or you could also write it as y equals 0, x plus 3. We'll talk more about that in a second. And then slope is undefined. That's a special case that's not a function. And we just described that line as where it crosses the x-axis. So let's say this one crosses at 5. The line would be x equals 5, and that describes a vertical line that goes through 5. So almost always when you're writing a rule for a linear function, you can use this template. And a template allows you to fill in the parts that you need to fill in for that specific rule, and you leave the other things steady. So for example, when we're using the y equals mx plus b, the y is going to stay the y, and the x is going to stay the x. And what we're going to be looking for is the slope, which we call the m. And the slope is always going to be multiplied by the variable x or d or n, since we're adding that number over and over x or d or n times. So n, for example, was our figure numbers when we're looking at linear tile patterns. We might be talking about the number of days that we're saving money or the number of times that we do something. So the x and the m are always next to one another because they're multiplied. And then the b is always going to be your y-intercept. It's always going to be when x equals 0. The y-intercept is always 0b. We talk about the y-intercept. We talked about when we're looking at a sequence, the 0 term or figure 0 is definitely our y-intercept when we're looking at tile patterns. And then if we're saving money or starting on a journey, the y-intercept is where we're starting. I want to remind you that we will be looking at 3 different ways of writing linear functions. These two are the same in the sense that here is our output, slope, y-intercept. And these you can use these two for any function. This particular one, it's a special case, and it's only when the input can be 1 and 2 and 3 and 4. And so we use this one in a sequence, and our tile patterns are sequences. And it's going to always start with 1 because we always start our sequences with figure 1. Even though we talk about figure 0, we always start with figure 1. So just want to make sure you recognize that all 3 of these are possible things you're going to see. I realized I was about to talk about this, that I goofed up on this. The other 2 things you always want to understand in a linear function is what the x is, or the n is. And normally that's how many times you're adding the slope to the b. It's the figure number when we're talking about a tile pattern. And your y is always going to be your total. Your f of x is always going to be your total. And your t of n is always going to be your total amount. Always, always, always. You might need to figure out what the situation total means, but it's always going to be your total, your output, how much you have when you have x equals 1, or how much you have when you have x equals 50. That's always going to be your output or your total. So where can you find the information? The y-intercept, you're always going to find right here when x is 0. And so we already know half of our equation. Then we have to go ahead and find the slope. And we've looked at change. We have the change in y divided by the change in x. And in this case, we can look right here, make that black. And we're going to go ahead and look at 3 minus 1. And then we're going to do the same here. When you have a graph, you can find the slope and the y-intercept by creating slope triangles to find the slope, if you want to. You can also pick 2 points and calculate it. You can do that if you'd like, if it's your preference. We'll look at that in another slide. So here we can look at the vertical change as being -2 and the horizontal change as being a +1. So we could call the slope here -2 over 1, or other people might draw the triangle in a different place. Let's say you drew it right here, right? And you might see that as up to back 1. So you would write it as 2 over -1. And it doesn't matter. It's still going to be negative. And you can write that as a -2. And those are all equivalent slopes. It just says it's dropping 2 for every 1. So the slope you can find on your slope triangle, and then right here, there's your y-intercept. Whenever x is 0, so it's 0, 3 in this case, so here's your b. This graph is the graph of the table from the previous slide. So y equals -2 is the slope times the x, and plus a 3. So if I give you the equation, you have to find what's next to the x. That's how fast it's growing. This is your slope. And then you need to look at the b. This y-intercept would be at -3, 0, -3. Now, this particular set of equations, excuse me please, is the stuff from the previous 2 slides. I want to make sure you understand that it's not that it has to be mx plus b. It can be b plus mx. Those are perfectly acceptable. What's important is that the slope is always attached to the x, the slope is always attached to the x, and the b is always a number on its own. So now there's the try these on the page for you, and I'd like you to go ahead and stop the video and do those problems and then turn it back on. And the next slide is going to be the answers. Now if you got all your answers right, sweet. If not, then you're going to go ahead and watch the rest of the video after that walks you step by step to how to use those things. So once again, turn it off, do the try these, talk to your neighbor, whatever you'd like to do to understand it better, and then check your answers. So the equation for A is 5x plus 2, or 2 plus 5x. The equation for B is 2x plus 3, or 3 plus 2x. The equation for C is y equals 12x plus 9, or 9 plus 12x. And I want to remind you that it doesn't matter if, at this point, if you're writing it in function notation or regular notation. The slope for the last one is going to be 1. So you could write that as 1x plus 3, or x plus 3, or 3 plus x. Those are all perfectly acceptable ways. Once again, if you got all of them right, or you understand what you did wrong, you can stop, and then go ahead and do your check for understanding Google form quiz. If not, you're going to go ahead and watch the rest of the video and have me help you step by step it one more time. So if you're looking to find the equation of this particular linear function, first we check to see if it's actually linear. So the first thing we want to look at is see is it growing by the same number every time. So let's check our y's. So when we're looking at tiles, our y's are actually t of n, and our figure number is n. So we're looking at our output here. Is it growing by the same number? So 12 minus 7 is 5. 17 minus 12 is 5. 22 minus 17 is 5. And it's growing by 1 each time, one figure each time. So our slope here is going to be 5 over 1, the change in y over the change in x. And so if we're talking about t of n equals m times n plus b, then we've already got our m. We're going to change it to a 5. If you wrote it as y equals mx plus b and changed the m to 5, that would be okay at this point because we're not being real picky about it, but I did want to introduce this to you. And then we just need the b. We need to find out what our zero term is. Since we know it's adding 5 each time moving up in figures, we can use that same information backwards to find out that 7 minus 5 is 2 and 1 minus 1 is 0. So our y-intercept is going to be right there at the zero term of 2. So this equation is y equals 5n plus 2. You can also write it as 2 plus 5n. Or you could write it as y equals 5x plus 2. That would be okay as well. Here, once again, we're looking for the slope and the y-intercept. We're looking to replace the m in the equation and with the slope and then the y-intercept. So the slope here, we've got a slope triangle we can draw if we want to. It's going up 2 for every 1. So the slope is 2. 2 for every figure number, and then the y-intercept is right here at 3, at 0, 3. So we're going to go ahead and include that. So this one is 2x plus 3. Once again, we're looking for the slope and the y-intercept. The slope is how fast it's growing. This one shows a vertical distance of 12, change in 12, and then 1 for the horizontal distance. So it's a slope of 12 over 1. And then the y-intercept right there is at 9. So you could write it as 12 over 1x plus 9. Or you can go ahead and write it just as 12x plus 9. Or 9 plus 12x. All perfectly acceptable. This last one, slope is 1 for every 1. So we have y equals 1x. And the y-intercept is at 0, 3. So we're going to have 1x plus 3. Other ways to write this, you could write it in function notation, right? But this one is not necessary. You can go ahead and write it as x plus 3. Those are all perfectly acceptable ways. But what it's saying is it's growing by 1 for every 1, 1 for every 1. That's the slope. And that it crosses the y-axis at 3.